Hello everyone, so today in this video we are going to discuss the question sending a sequence over the network which was asked in Codeforces Round 826 Div.3. In this question we are actually given an array B and we have to tell whether we can segment this array B into an array A or not. So let's understand this question with the help of the example which is given here. What we can see that in this example, actually in the question we are given these array B, we are given there are 4 B arrays which are given to us here. Out of these 4 arrays we are given any one of them. So let's say the B array which is given to us is B 1 1 2 3 1 3 2 2 3. Now we have to tell whether this B array can be segmented to form an array A or not. If it can be segmented to form an array A, then we will report the answer as yes, else we will report the answer as no. So let's see how we will segment this array B to get an array A. Let's say I put this one here in the array A. So I say okay, this one I had put in the array A and this one is actually of length 1. So this one is actually of length 1. Now again, then I will put, let's say I put these 3 values in the array in, let's say in segment. So 2 3 1. I can say okay, these 3 values I put in, that is these 3 values 2 3 1 I put in array A and these are having a size of length 3. Now let's say I put to, let's say I put to, I say okay, let's say I put now these 2 3 and I will say okay, these 2 and 3 are of length 2, so this is 2. So I easily be able to make, or I can say I easily be able to segment B into A such that the A formed is like one, here 1 is present and after that its length is present, that is of 1. Here 2 3 1 are present and its length is present 3. Now first here length is present 2. Now after that 2 elements are present. So we have to actually segment these array B into an array A of this form. So whether we have to tell whether we can segment this array B or not and report the answer as yes or no. So one thing which we can observe in this question is that we are given some elements. Let's say we are given some elements and we are given, let's say, some range of elements, and after some range of elements we are given its length, and in some of the cases first we are given the length, then we are given some of the elements. So in this way the array will be formed. First there are some elements, then length will be there. It might be possible then first there will be length and then there are some elements which are present there. So we need to tell whether we can make it or not. Okay, so we will solve this question using the concept of dynamic programming. So let's first understand how we'll approach this dynamic programming question. So what we will make a choice that we will make a thing that let's say this is my array and there are some elements and the length of which, and there are some elements and length of it. Let's say in between there are 3 elements A, B and C, and after that we are given a number 3. That is, these elements A, B, C are having a length of 3, therefore we have written 3 here. So what we can observe from here is that what our target is. Actually when we are trying to write the DP transition of it, what we will remember in the mind is we have to make the last value of the length always true. What I mean to say is, let's suppose in the question, let's say here it is given ABC 3. So what my target is, I want to make this 3. That is, suppose this is ith index, this is I plus 1th index, this is I plus 2th index, and this is I plus 3th index. So my target is to make I plus 3th index true. I know now in this situation it might be something, what do you mean by making the I plus 3th index true? I will tell you later on. Now for that you will remember, you will just learn it what I am trying to say. Suppose the A is at ith position, B is at I plus 1th position, so until 3, the value 3, that is the length of ABC, is at I plus 3th position. So my target is to make the I plus 3th position true. If instead of this there would be A, B, C, D, 4, then my target would be to make this position true. If there it would be, let's say there would be, suppose 5 A, B, C, D, E. Suppose the first length is given to us, then 5 elements are given to us. Then also our target is to make the end element. Here the end element in this section, in the above one, A, B, C, D, 4. You can see the end element is 4. So my target is to make the position of 4 true. Here in 5 A, B, C, D, E, you can see the end element is E. So my target is to make the end element position, that is the position of E to be true. So what my target is to make end element true, end element true, whether it is length or just a number, or I can say or just a number. So what is the end element? If suppose in the array there are some elements here and there are some elements here, and here we are given A, B, C, 3. So our target is to make this position true. Suppose now it is given 4 A, B, C, D. So now my target would be to make this position, D position, true. So let me give you a small example related to it. Suppose my array given to me is A, B, 2, 3, A, B, C, 4, A, B, C, D. So my target is this first section, this is second section, this is third section. So my target is to make this position true, to make this position true, and make this position true. Okay, so my target is to make all these positions true. So don't you think if I able to make the end position true, if somehow I will be able to make the end position true, then answer would be yes, else the answer would be no. Again I am repeating, if I able to make the end position true, actually I am traversing from left to right. And while traversing from left to right, if I able to make the end position true, then my answer would be yes, else my answer would be no. So let's understand the approach to this question. Let's say the array given to us are that only A, B, 2 and 3 A, B, C, then 4 A, B, C, D. Okay, so what conclusion you can make? Let's suppose instead of ABC I should put some of the numbers. Let's say I put some numbers. Let's say I put numbers as, let me clear out this space first. Let's say I put the numbers as 2, 2, let's say 2, 3, 2, 3, 4, 5, 6 and 4, 3, 2, 1, 4. One combination might be this 2, 3, 2, this would be the length, this 3, 4, 5, 6, this 3 would be the length, and this 4, 3, 2, 1, 4, this 4 would be the length. Okay. So what our approach would be, we will traverse from left to right, and what we will see is, okay, we come to this point. At every instant we will do two types of analysis. First we will do the backward analysis and then we will do the forward analysis. So I am at index 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. I am at 0th index. I will ask in the 0th index, at every instant, suppose I am at 0th index, so I will do two analysis backward and forward. So I will ask to myself whether this 2 can be the length or not. I am asked myself, okay, this 2 can be the length or not. So I will first see backward. Is there are 2 or more than 2 elements present? I will say no, there are no 2 or more than 2 elements present in backward. So I will say, okay, it fails the forward analysis. It might, okay, so I will ask whether it fails the backward analysis. Why it fails the backward analysis? Because we here from 2 there are no elements which are, there are neither, even not a single element. We want actually two elements which are before this zeroth position. So as there are no elements which are before this zeroth position, so I will say okay, it fails the backward analysis. Now I move to forward analysis. What I will say is, okay, I will see two positions ahead. Okay, from 2, we can see that there are two elements which are ahead of it, which are 3 and 2. You can see these are two elements, 3 and 2, at the first position and at the second position, which are ahead of zeroth element. So I can say, this 2 can be the length, and this 2 can be the length of the segment, and the elements in the segment are 3 and 2, which are present at first position and the second position. So as you know, I always said that you have to mark the last element of the whole section true. So I will mark this section 232 section. I'm saying about the section 232. So I will mark this 2 as true. I will say okay, this true, or I can say this second position, the second position, I will mark it as true. Now my pointer moves to another one. I will say okay, whether this 3 has, whether this 3 which is present at first position, whether there are 3 elements which are before first position. I will say there is only one element which is before the first position. So okay, 3, that is the 3 which is present at the first position, also fails the backward analysis. Now I will see in the forward direction whether there are 3 elements which are present after this 3. Yes, I can see okay, there are 3 elements which are present after this 3. Those 3 elements are 2, 3 having value 2, 3 and 4, which are present at index 2nd, 3rd and 4th. So I will say okay, it might be possible that this would be the segment having a length of 3 and the elements are 2, 3 and 4. So what I will do is, I will mark this 4 as true, because this whole section, the last element would be 4. So I will mark this 4, or I can say the fourth position, this fourth position as true. Now my pointer moves to this. So what I will do is, I will see, okay, I will ask whether there are two elements which are back of it. There are two elements which are back of 2. That is, whether there are two elements which are back of the second position. I can see yes, there are two elements which are back of the second position. If there are two elements which are back of the second position, what I can say? Okay, let's here discuss more about it. Okay, I will discuss more about it in later section. First, you will what you will remain in your mind is, from 2 we can see okay, there are two sections, there are two elements which are behind it. Okay, so 2 is fine. Actually, there is one more constraint which I will tell you when we are moving ahead. So we will say okay, let's do its forward analysis. By doing the forward analysis, we can see okay that there are two elements which are after it, 3 and 4. So as there are two elements which are after it, 3 and 4, which are present at third index and the fourth index. So what I will do is, I will say okay, this might be a section. So I will mark this 4 or 4 value, or I can say the position 4 again as true. It's already true. It remains as true. Then I move to the pointer to this value. Okay, I will ask to myself whether there are 3 elements before it. Yes, there are 3 elements before it too. Okay, so everything is going fine. So if there are 3 elements before it, you are thinking that if there are 3 elements before it, so I should mark it as true. So there are 3 elements before it. Because of this reason, this time I mark it as true. But later you will realize this is not the only condition because of which we mark anything true in the backward analysis. You will understand it in the later on in the video. So now what I'm saying is, as there are 3 elements which are before the third index, or I can say the value 3, that is the values are 2, 3 and 2. So I will say okay, let's mark it true. it passes the forward analysis. Now we will see in the forward analysis. It might be possible that the section would be this. If the section would be this, then the last element would be 6, which is present at index 6. So I will mark this also as true. Ha. I have also done the forward analysis and backward analysis of 3, or I can say the element at index 3, or I can say the value 3. Now I will move to 4. But when we see 4, we see that okay, the 4 elements are already present. 4 elements are already present in the back of the 4th index, or I can say the value 4. So okay, this would be fine. So let's do some change in here. Let's say I change this 4 to 3. Let's say here it is not 4, here it would be 3. Here it would be 3. Okay, let's say here it would be 3. Now I came to the position, this position, that is the 4th position, 4th index position, which contains the value 3. Now what I will do is I will ask 3 whether there are 3 elements before it. You will say okay, yes, there are 3 elements before it. These 3 elements are this. You can see here is this 3 which is present at 4th index position is already marked true. Let's consider that this is not marked true. Let's think of that now. Suppose it is not marked true. Then think of about the situation which I am going to tell you right now. I know this is marked true, but let's think that it is not marked true, and then go through the situation which I am going to tell you right now. This 3, you can see that this 3, behind this 3 there are 3 elements which are 3, 2 and 3. Behind this 3 which is presented in index 4, there are 3 elements 3, 2 and 3. So what we can see is these 3 elements 3, 2 and 3. So we should say that okay, now what you have to think is this is not true. So what you will say, okay, there are 3 elements back of it, so we should mark it as true. No. There are 3 elements before it. This would not be the only reason we should mark it as true. In the backward analysis, reason being, if there are 3 elements before it, then it means that is, if there are 3 elements C2 before it, it means the previous section should end at this. I am marking with orange. The previous section should end at this, should end at 0th index. And if the previous section should end at 0th index, so don't you think this 0th index, that is the value 2, should be true? Yes, this 0th index should be true. But as we can see, if we consider this whole 4 elements, 3 to 3 and the length 3. If we want to say okay that 3 to 3 and length 3, this should be true, we have to say that the previous section should end at this. And how we can say, now I am marking, bolding it with purple, how we can say that the previous section is true? That is the 0th index. How we can say that the previous section end at 0th index? We can say that the previous section end at 0th index only if it was true, and I can say that it is not true. So I can easily and safely say this section, that is, a section comprises of first index, I am writing it down here, second index, third index and fourth index. And that is, this section can't be a section. This can't be a section. I am writing down in the lower bottom, you can see the first index, second index, third index, fourth index comprising the section. The values 3, 2, 3 and 3 will not be forming a section. This is for sure. This is for sure. So let's come back to the topic again. When 3 is true, so it is already true. So let's go to the next section. We will see, okay, for 5 we have actually done the forward. Let's first, for this 3 which is present at 4th index, let's first do the forward analysis also. Here we can see after that there are 3 elements. So we can say okay, this 4 is also true. This 4 is also true, which is present at 7th index. Now we move to 5. We say okay, there are 5 elements which are present in the back of it. You can see that there are 5 elements which are present in the back of it. And you have to say whether a previous section has ended before that or not. You can say there is nothing. If there is nothing back of it, it means previous section has ended. So we will say okay, in the backward analysis it is passed as true. Why? Because we can consider the index -1 to be true only. Index minus 1 to be true, but not index minus 2. We can consider the index minus 1 to be true, but not index minus 2. You can easily be able to understand why I'm saying that we can't consider index minus 2 to be true. Let's do the forward analysis. We can see, okay, the 5 elements are present. After that, after this 5 which is present at 5th index, so we will mark this 1 which is present at 10th index also as true. Now we will move to 6. We will say, okay, 6 elements are present, and we will say, okay, in the forward action no 6 elements are present. In the forward action no 6 elements are present, so this can never be a section. But this in the backward direction can be a section. Now we will move to 4. We will see, okay, first we will do here for the 4 first which is present at index 7. First we will do forward analysis. We can say, okay, the 4 elements are present, so okay, the last index will be true. In the backward analysis we will see that the 4 elements are present at the back of 4, that is 3 3 5 6, and index which 2, that which contains the value 2 is also true. So we can say, okay, the 4th position is true, although it is marked already true, but I am just doing this. Similarly for 3 becomes true. Similarly you can see 2 also becomes true, but at the end you will see that the last positions become true. So you will say, okay, the answer is yes, else the answer would be no. And you can also see here in this case the answer is yes. If you put more efforts, you can also be able to make the sections out of it, that which sections will work, which sections will won't work. But here we have to only tell the answer in yes or no. So this is the approach how we will move forward. Let's understand the code section of it. In the code section I have also written down the explanation. If you want to, let me recompile it again. So, case 1, ABC3 we are given. This 3 is actually length. What we are actually, I am trying to make the end true. We always make the end of length true. We always make the end of length true. And here I had explained what does this section means, that and then I had explained the whole section of the code here. Then I write the DP here. I have done the two analysis, first the forward analysis, then the backward analysis. In the forward analysis, I've said, okay, and there one more thing in the forward analysis. Suppose I am currently standing here and I am saying, okay, there are 4 elements after it. Okay, so if I say this 4 is my length, for that I must say this 6 must be true. The 6 which is present as 6 index would be true. Let me clear it some out of it. If I'm saying that this is true, if I'm saying that this should be the length, as there are 4 elements after it which are 3 to 1 4, then I must say this 6 then I must say this 6 should be true, because if this is the length, it means there is some section which should end here, which should end here. There must be some section which should end here. So I must say this 6, that is which is present as 6 index, should be true. So here I have done, if I minus 1 is greater than or equal to 0 and dp of I minus 1 is true, then we will find the index I plus vi, and if that index is less than n, we will make that index true. If I minus 1 is minus 1, I've already said consider minus 1 as to be true, because if we consider minus 1, it means there are no sections which are back of it, 0 sections, and it is properly following the analysis. So I will mark, okay, dp of I and d as true. Then I will do the backward analysis. I will say, okay, if value, that is the index I minus vi minus 1, if it is minus 1, then I will mark dp of I as true. If it is greater than 0, then I will check whether it is true or not, dp of val is true or not. If dp of val is true, then I will mark dp of I as true. If dp of n minus 1 is true, then we will see out yes, else we will see out no. If you will like this video, do share and subscribe. Thank you.